Algebra 1. Here we go again, guys. We're in chapter 8 now, all right? We are officially in chapter 8. So here we go. Let's jump into section 1. We are talking all about exponents, all right? Exponents, there's a lot of exponents in this chapter. We're going to get into a little bit of square roots in this chapter. And as I've said in class, I'm sure more than once, we're kind of taking it a little bit of a step up, but I think section 1 here has a nice, smooth intro to it. All right, so nothing to be worried about. Let's jump into it. Okay, as you can see on your screen here, we got a title of Applying Exponent Properties with Products. Products, we're talking about multiplication here. Okay, so we will need to copy all of these charts right here, but you can see I've actually highlighted the examples. So what I'm really telling you is you need to copy at least the highlighted example stuff down. So right here, and right here. Okay, listen, some of you guys, I know you're not doing this and you're kind of paying the price for it. All right, come test time, you're not knowing what you need to know. So let's start fresh with a brand new chapter, a brand new first section, and do the right thing here. Take the time, copy the notes, earn that grade. All right, I know you can do it, but if you don't put in the time, it's not going to magically happen. Now let's jump into it. Okay, let's zoom in here and take a look at what this first example is talking about. What you need to notice is that you have the same base number. All right, that big number, that's the base number. What if we have the same base number? You could also think of it even as a variable. You could have both of these as x and the other one's x, or y and the other one's y. As long as the base is the same, then you can focus on this exponent right here and actually just add those exponents, and that's how we're getting 9. Okay, 6 plus 3 represented right here is what's going to give you 9, and the whole thing having the same base is just 5 to the power of 9. And then you could go one step further and actually figure out what that is. All right, so this is when you have the same base number. Let's take a look at the next one. All right, what if you are given just one base number to a power, and then the whole thing is brought to another power? That's what we're talking about here. Then you just simply focus on the exponents. If this is what you're dealt, one base to a power to another power, then these exponents will be multiplied by each other. So one of the clues that you should see is you're only dealing with one base, but two exponents. Then you will be multiplying those exponents, and 4 times 2 is what gave us 8. And like I said prior, you could go one step further and figure out what 3 to the 8th power is, but that's fine. You don't need to in this case. All right, let's take a look at the final example that they give us. Okay, you will notice that we have two different bases, both brought to the same exponent. So you can kind of go backwards a little bit. If you have two different bases and one exponent, that means that this exponent right here, it's like it's being distributed to both of these bases. And that's why you get 23 to the power 5, because we distributed that power 5 to 23, and then 17 to the power 5, because you distributed the power 5 to the 17. And so then you can like expand it out a little bit, because this right here is a little bit more expanded than this right here. Okay, so if you have different bases, but then the same exponent, you can see you could even go backwards and rewrite it just like that. Okay, so that would mean you could figure out what 23 times 17 is, get a bigger number, and then just put that bigger number to the power 5. And that would be the same answer. Okay, all right, let's do some example problems here. All right, if you notice this guy right here, it looks like it doesn't have an exponent, but it does. There's always an exponent written. What is that exponent? a 1. So let's write that in there because they won't give that to you, but it does exist. It is there. So this goes back to that first example. We are dealing with the same base, but then we have different exponents. So same base, different exponents. That means that we can take this base of -5 and then treat it as 1 plus 9. Okay, that's what you do when you have the same base, different exponents. This will then equal -5 to the power of 10. And that right there we are good with. We don't need to expand it, make it this crazy big number. Just keep it as it is right there. All right, first example problem done. Second example problem. Again, what do you notice? There is a base, and it looks like we're missing an exponent. What is that exponent? It's going to be a 1. There's always an exponent there. So now you should see, same base. All three of these guys are x's. Same base. Doesn't matter if it's a variable or a number. Now, add the exponents up because you have the same base. So let's do that. Same base, x, but then the exponent 2 plus 5 plus 1. So there's our base, and that will be to the power of 8. 2 plus 5 plus 1. That's example problem number 2. All right, let's do this one. Now here we go. We're looking at one base to a power to another power. So this goes back to the example problem where if you're dealing with one base, two exponents, you will multiply the exponents. All right, and if you forget, that's up here, right there, that one right there. Okay, you have one base, but two exponents, and you multiply those exponents. All right, so if that is what we are dealt, then we have our base, exponent multiplied by another exponent, being our base to the power of 4 now. And that's all we have to do there. So you're going to find, if you can remember what these properties are and what to do when you're given, maybe the same base, or maybe you're just given one base, or eventually we're going to find different bases but same exponent. If you can remember these properties, then these problems work very quickly. All right, it's important. Remember these properties. All right, let's do another one, but you will notice we got parentheses, we got brackets, all that fanciness seems like it should be more confusing. It's not. The reason why we're dealing with parentheses here is because of that negative sign. All right, they want to keep negatives all represented in parentheses. Then we put these brackets here so that we're allowed to put another exponent on the outside. All of this mumbo jumbo is to say, here's a base, one base, with an exponent to another exponent. It's the same property as the one we just did. All right, so here is our base, exponent multiplied by another exponent. Remember, when you're dealt one base and you have an exponent and another exponent, you're going to multiply those exponents. Okay, but if you have the same bases and then these exponents, then you are adding those exponents. So that's why those two are different. So now there's your base to the power of 20 because we multiplied 4 times 5. All right, that's example problem 4. Let's do example problem 5. Now we're stepping it up a little bit. Okay, if you ever have a full expression here, notice all of that's in parentheses, so that's an expression, then an exponent on the outside, you essentially are distributing this exponent into everything in the parentheses. So let's show that. All right. We're going to have 9 to the power of 4. Remember, what do you do when you have an exponent to another exponent? You multiply. So then we're going to have x to the power of 3 times 4, and then y to the power of 4. The reason why that one's simple, because there's a 1 there. 4 times 1 is going to equal 4. All right. So let's expand this one out. Okay. Now, up to this point, I have not made you guys expand anything out. And by that, I mean, I didn't make you figure out like what 9 to the 4th power is, but now you have to do that. Okay. So if you think about it, you have 9 4 times. 9 times 9 is 81. Well, then there's going to be another 81. So 81 times 81, we're dealing with 6,561. Okay, so this makes this. Then we just need to simplify the exponents, all right? X to the power of 12. 12 was 3 times 4. And then y to the power of 4. That's it, okay? So this one right here, that's everything expanded out. And we got one more example problem to go. Okay, so again, you're going to see an expression right here. It's all in parentheses, so it's all together. This expression and the exponent on the outside means that we need to distribute this exponent to both parts, or all parts in the parentheses for that matter. So the 4 is going to go to the 5 and the 2. This 5 on the outside, we're going to deal with that at the end. Okay, he's kind of that connected but separated just enough that we don't need to deal with him in regards to that exponent. This exponent only goes to what it's connected to in the parentheses. All right, so we're going to have this 5 on the outside, but now we're going to have that exponent, 5 to the power of 4, x 2 times 4. Okay, that 4 went to the 5. That's this guy right here. Then that 4 went to the 2. That's this guy right here. So now let's keep going. We still have that 5 on the outside. That's that guy. But now 5 to the power of 4 becomes 625. The 625 is the 5 to the power of 4. All right. And then you have x to the power of 8. Now we need to incorporate the 5 and multiply it by the 625. Okay. And that is going to give us 3,125, then x to the power of 8. That's everything right there. Okay. So let's zoom out and put all that right there. That's all 6 example problems worked out there for you. All right. You must have these down. You must take the time to do this. All right. I understand that you may not, but it is your grade and your chapter that you can take control of and work very hard and earn that good grade, or do nothing. And it's not going to help at all. All right. So let's start strong. New chapter, new section. Let's do the right thing. Let's work hard. All right. We'll see you guys in the next video.